So good morning. Welcome to the first live broadcast that Women in Aerospace Europe UK is trying out. There may be a few teething problems at the very beginning. I'd like to introduce and thank Mamatha Maheshwarappa for being our first person to do a live presentation. Mamatha is from QinetiQ and is a spaceflight electronics systems engineer, and recently was the crew commander at the Mars Desert Research Station, which you'll tell us all about today. A few technical issues. Anybody that joins, please keep your video off and the microphone muted. And if there are any technical issues, then you can message Claire McNamara, who kindly has given us the Zoom software to use, and she will try and sort them out. To ask a question, you can send it in the chat box to all, either hidden under chat or through the participants button. If you send it to everybody, then at the end, Kerry Sands will read through the questions for Mamatha to answer. And so now I will hand over to Mamatha.
Thank you very much, Liz, for the introduction. I'm Mamatha Maheshwarappa, working for QinetiQ Space UK. I started my journey in space 8 to 10 years ago when I was a systems engineer for first Indian Pico satellite, which was designed, developed, tested by undergraduate students, and it was launched by PSLV, which is Polar Satellite Launch Vehicle from India in July 2010. Then I moved to UK to do my master's in space technology and planetary exploration, did my PhD in software-defined radios for concurrent multi-satellite communications, which is basically talking to more than one satellite at any given time using single setup. And then I joined QinetiQ last February. I'm a spaceflight electronic systems engineer working on various projects such as frequency monitoring payload and transceivers for ExoMars Lunar Pathfinder mission in collaboration with European Space Agency. Last year, I also won Derek Barter Award from QinetiQ, which is mainly for graduates to develop and to improve their technical abilities. And I use this bursary for my 2 weeks expedition at Mars Desert Research Station, which I'm going to talk about today. So before I start with the experience at MDRS, I would like to give an overview on what other organizations such as NASA and ESA are planning for manned missions in future. NASA started its journey to Mars with an aim to send astronauts to asteroids in 2025 and to Mars in 2030s. So their path begins in the low Earth orbit on board International Space Station, the microgravity laboratory where astronauts spend a lot of time understanding how hard it is to live and work in space for extended space flights, and also to come up with a technology which can help to take humans in future to Mars or any other planets. So the next step from there is to send a robotic mission to an asteroid to grab and redirect that around Moon. And astronauts on Orion spacecraft will explore this asteroid and then bring samples back to Earth. And then will be a mission to Mars. So though there have been many missions like Curiosity, Spirit, Opportunity, and ExoMars, which have given us a lot of knowledge about how Mars is and about their terrain and so on. But there are other questions unanswered, such as, was Mars home for microbial life? Is it now? Is it safe for humans to go there? And what can this red planet teach us about our own planet's past, present, and future? So while NASA and other private organizations are concentrating on Mars, ESA is planning to have a cluster of laboratories, which is also known as Moon Village. So that is just to explore their experience or the lessons learned on board International Space Station and test the technologies such as like 3D printing, which can be used to build structures, and that can help us reduce the cost for the transportation of this big structures to Moon. And this technology can be used in future to send missions to Mars as well. So though these manned missions are decades away, scientists are also focused on other challenges like physiological challenges due to loss of gravity and psychological challenges due to boredom, confinement, and people being away from their family and friends. So organizations such as NASA, ESA, and other private sectors like Mars Society have come up with ground-based studies to simulate the effect of extended space flights. So I had been on one of these analog sites, that is Mars Desert Research Station, but there are several others like Flashline Mars Arctic Research Station, which is in northern Canada, which is also owned by Mars Society, and Arctic Mars Analog Expedition, which is in Norway, owned by Norwegian Space Agency and ESA, also with NASA, and Concordian Earth Station, which is a French-Italian research station where they send astronauts and scientists, doctors for about six months to 1 year to carry out research, and Hawaii Space Exploration Simulation, which is on the slope of Mauna Loa volcano, which is used by NASA astronauts, and they spend up to 1 year carrying out experiments there. So what is common amongst all these Mars analogs is that the size of the habitat is confined. That is because of the launch ferry will have a limited space. So we may need several launches to get the entire habitat on Mars. And also, so these Mars analogs would help people to understand how to carry out geological and biological experiments, because the terrain is similar to Mars. And also, if these facilities are big enough, or are they too small for people to live and carry out experiments, and also to assess crew selection process. And most importantly, to inspire people. I was one of them who got inspired by MDRS when I learned about in one of the conferences last year, and I always wanted to experience the life of an astronaut and to be ready just in case, as said by Dr. Chris Hadfield. I was, as a kid, inspired by Kalpana Chawla, who was the first Indo-American astronaut. Unfortunately, we lost her in the space shuttle accident. And Sunita Williams, who is another Indo-American astronaut, was a record for having the longest, who has spent the longest time in spacewalk as a woman. So when we thought about participating in MDRS, the first thing I had to do is to come up with a team. So then I started contacting my friends, and they contacted their friends, and finally we came up with a team of 6 people, 6 crew members, and they had different designations based on their qualification and experience. So we had crew scientists, biologists, engineer, astronomer, and geologists spread across the world. So once we had the team, we also had to come up with a research proposal with objectives that could not be carried out anywhere else on Earth. Say suppose I'm from an engineering background, I can test the transceiver or radio anywhere, but it had to be something focused mainly on geological experiments or microbiology experiments. So as we all know, the missions such as Curiosity or ExoMars, they target on finding if there was life on Mars or if there is now. So by any chance, we should not be taking microbes from Earth. Either it could be through manned missions or unmanned missions. In order to understand the contamination that could be caused, we carried out the experiments. That's the first one listed here, to characterize the transference of human commensal bacteria. That is through the crew members who have been visiting MDRS so far, including ourselves, and come up with a zoning methodology depending on the contamination. And this was guided by Professor Lewis Dartnell from University of Westminster. I was fortunate enough to get in touch with him. I'd like to thank Matthew Cosby, who was the chief communication engineer at QinetiQ then, who got me in touch with Professor Lewis Dartnell. And he trained me to carry out these experiments at MDRS. And that is one of the important qualities of any astronaut, that is to be able to adapt and carry out experiments in different areas. And the second experiment was very much related to the first one, where we were trying to come up with a protocol to minimize the contamination on Mars. So this was guided by Dr. Penny Boston, director of NASA Astrobiology Institute. And the third experiment was to carry out or investigate the effect of vitamin D tablets on the growth of fenugreek plant. Why vitamin D? Because surface on Mars would get only like 44% of the sunlight as on Earth. So we wanted to induce that by adding vitamin D tablets and see if that affects the growth of fenugreek plants. And then we also carried out several experiments to understand the magnetic materials of different rock samples. And also there is a study on drone technology to guide the extravehicular activities in remote places and aid crew members with no or limited communication links. And also we were part of a survey from NASA, which was basically to understand the psychological changes that we were undergoing even before the mission. Like we had to start 5 days before the mission and carry out this experiment throughout the mission, and also 5 days after the mission. So when we submitted a proposal with all these different objectives, after 2 levels of screening, we got selected as Crew 174, which started on 28th of January and lasted till 12th of February. At the same time, I was at QinetiQ applied for a Direct Barter Award, which I explained before. It was a bursary towards improving the technical abilities or personal development, and I won that award, and I spent that bursary towards this expedition. And I was also trained by one of our principal psychologists from Human Performance, how to handle team in such an stressful environment and take decisions at the same time. And also what we did not experience at MDRS is the change in the gravity. So for which I went on a trial run at Farnborough Centrifuge. So here is a snippet of the video. I go up to 3.6. You can see the values changing here.
And control, we're clear to run again at 3.6 G, 15 seconds.
Stand by, 3.6 G, 15 seconds.
That's great. And when the machine starts going strongly, do your leg squeeze.
Okay.
It takes a few seconds to get going. So, good time down. That's good. And is it clear now?
Yes.
Good. No. 15 seconds is quite a long time, isn't it? Good. How was that one?
I didn't notice any change.
That's fine.
Fine, throughout.
So what we do with the G training for our long-term subjects is that we get them to do that in varying degrees of intensity with higher and higher G levels in order that they learn how to keep the vision clear and to keep...
That was the video. Also, we were the first all-Indian crew to participate at MDRS. So we got a lot of media attention. So there were many coverages from national newspapers like Deccan Chronicle and Times of India. So what's interesting about these different analog sites is that they try to have modules which are similar to concepts given by Mars One or SpaceX. For example, if you see here, there are these different modules connected through a tunnel, similarly here. So these sites have the same concept. So you can see this is the greenhouse, here is the science dome, and we have the habitat just behind this, and they're all interconnected through this tunnel. And we also used ATVs, that is all-terrain vehicle, and also rovers to travel around MDRS site. And then here is this floor plan of the habitat, how it looks inside. So this is the lower deck and this is the upper deck. So we can, you see the engineering airlock. So this leads to the tunnel that I showed earlier. And there is shower, toilet, workshop, and also EVA preparation room and EVA airlock from where we go for extravehicular activities. And also there are stairs to come up for the upper deck, where you can see all the individual crew rooms, and there is kitchen, dining table, and workstation. So this is about 8 meters in diameter. So it's very confined. There, all the cubicles are very, very small, and we all have to live there for 15 days. I mean, you're not connected to the external world at all. And this is the complete MDRS site. That is, here is the hab, and probably it extends up to 10 kilometers radius. And this is where we used EVAs and ATVs and so on to travel around and conduct experiments. So this is how our daily schedule was looking like. So we used to start our day at 7 o'clock in the morning with team briefing, and then exercise for about 30 minutes, and then also have breakfast before 9 so that we can go out for extravehicular activities. And that would take around 4 to 5 hours because the rovers were really, really slow, which were about 25 to 30 miles per hour. And then these regions of interest, which we targeted were quite far. So at any given time, there have to be two crew members, either inside the hab or outside for extravehicular activities. So when people go out for extravehicular activities, the crew members inside the hab would carry out their experiments and also prepare lunch for everyone and so on. So we used to have lunch together and then carry out other activities like green hab, research and cleaning, etc. And also there would be debriefing of the entire day at around 4 o'clock, followed by a tea break. And then came the interesting part where we had to do reports each day. And so we were supposed to submit like 5 to 6 reports every day, including the health of the habitat itself, which is called operational report, mainly by crew engineer. And then we used to have SOL summary. SOL is Martian day. So we used to have a summary of whatever we have done throughout the day and send photographs. And also we had to inform the mission support beforehand where we are going the next day, like for extravehicular activities, where we are going, what is the purpose, and who all are going. And also submit the report of what we have done on that day. So with all these, and once in 3 days, we used to have commander's report and journalist report and green hab report, science report, etc. So once we are ready with the reports, then starts the CAPCOM. CAPCOM is the capsule communication. That's when we talk to people on Earth. So that's basically talking to mission support. So as a commander, I had to review all these reports before I sent them out. And that's when we report all our issues of that day, and if the day was fine, if we had any troubles, and if all the crew members' health was fine, etc. You could actually talk to them and get advice. But that was not real time, so that had delay as well. And then followed by that was dinner, and of course there was some time for recreation, but trust me, we would be so tired that we spent almost 8 days to watch one movie. So yeah, you can understand how tired we were, and then we used to go to bed. Here are some pictures of the zoning methodology and planetary protection experiment that we conducted. So we had to collect samples from 25 different locations within the habitat. So you can see we are planning the different locations and then collecting samples within the habitat. And then this is the similar thing that we are doing for the extra collection of external samples. We had to go out of the habitat, wear the spacesuit, and collect soil samples at varying distance, like 1 meter, 2 meters, 4, 5, 10, and also from places like where the previous crew members have never visited. That is to get a reference soil sample. And when we go out, we have to have this life support system on. That is, in real scenario on Mars, we would not be able to hear to another crew member because of vacuum or a very thin atmosphere. So we had to wear microphones first, and then wear the life support system. Basically, what this does is to circulate the air, and then that's fed into the helmet here. And so that's how we are ready to go for an EVA. And we also have an EVA airlock, and then we use rovers to travel around MDRS site. So this is another experiment I mentioned earlier, that is to see the effect of vitamin D on the growth of Fenugreek plants. So we collected soil samples around MDRS, and we also had taken some soil sample from Earth, like from outside MDRS site, and we had mixed that in different proportions, and also we added different levels of vitamin D to these different parts, and so we observed the growth of root and shoot over those 2 weeks. And then we also carried out certain experiment to see the magnetic mineral distribution across different samples from different sites around MDRS. And this is how the food looked like. So we were given dehydrated food. This is, for example, dehydrated onion, and this is carrot, and you can also see dehydrated egg here. So basically we had to prepare everything from these ingredients. So we were not allowed to take any other food from outside. And then this is how small our rooms were, individual rooms. And this is basically kitchen, dining, and living room, everything put together. And these 2 tanks here were our water tanks for the entire 2 weeks and for all of us. And there was a pump to pump the water from these external tanks to the internal overhead tank. And there was another pump for which could pump from internal overhead tank to all the taps within the habitat. So I'll come with the issues now. So one of the challenges was we had this pump, internal pump, which broke down after like 3 to 4 days into our mission. And we had no water at all inside the hab. So what we did was to put a huge pipe inside this and then suck the air from the other end. So we used to fill the tubs using that. And basically we couldn't inform the mission support until the end of that day, because we are on Mars and we can't contact them as and when we want. So I had to call for an emergency EVA, where we went outside the habitat to bring the water from the external tanks to inside before we did this. And also when we contacted them and when we explained our problems, they would not send someone to fix it. Instead they sent us all the manuals, which we had to read and see what was the problem ourselves. And so one of which was to check the filters, but then they were still okay. The pump was broken, and they replaced that after like 4 to 5 days. And the second challenge was when we got lost in the middle of an EVA. We were not, because there is no navigation, we were using the map to follow the route, and there was one time when we got lost. So it took hours to get back to the normal route. Also, we had fun moments, like we enjoyed sunrise, socializing with people. I celebrated my birthday there, and there were many journal people who came to interview us and to share our experience. And yeah, so we definitely enjoyed being there as well, apart from all these other challenges. So here is a video which will sum up whatever I've said so far. The final part was the simulation of a scenario where we lost a crew member, and the drone helps to find the lost crew member. So here are some group pictures. This is inside the habitat, and these are our individual rooms. So we are in front of our rooms. And then came the final stage where we had to hand over all the responsibilities to the next crew. So, we trained them how to use the life support system and the rovers, and where to take the readings each day across the habitat facilities, like from Green Hab or from science laboratories or within the hab itself. And of course, we learned a lot of lessons. Definitely water is precious. We understood the importance of water and having fresh vegetables. I almost ate salad for like a week coming from MDRS. And then we also learned the importance of social life and the fresh air we breathe. And I personally learned a lot of leadership qualities and how to handle stress and take decisions in that stressful moments. And team working is definitely very, very important, and how we can isolate ourselves from this internet. At these days, it's very difficult, I think. Finally, I'd like to thank each and everyone who have been supporting MDRS and our team. So with that, I'm happy to take up questions.
Okay, thank you, Mamatha. It was a really nice presentation. I'll do some of the questions. So the first is, Mamatha, you talked about the impact of stress on teamwork. What would you say is your biggest learning in this respect?
Especially taking decisions. Like, for example, I explained the scenario where we had no water at all inside the habitat, and we had to take a team decision and go outside of the hab, and I had to call for an emergency EVA. That's called emergency EVA because the mission support wouldn't know that we would be out at that point. So if something goes wrong, for a crew member or with the habitat or anything, then I'll be held responsible. So those crucial things. And at the same time, water is very, very important within the hab. So we definitely needed water, and I had to take that decision. So that's something I learned.
Okay, and another question is, what were the conclusions of your experiments, and did they go as you expected?
Okay, so because 2 weeks is a very limited time, and the laboratories there are not well equipped for all the experiments that we wanted to do, we have brought all the samples here, and I'm in touch with Professor Lewis Dartnell, where we are carrying out the analysis of the samples that I brought here, and we'll be publishing papers soon, and that applies the same as with other experiments as well. For example, with Penny Boston and other professors from RIT and so on. So we'll be analyzing this. And this is very similar to what happens in real scenarios, that they conduct certain experiments and bring back samples from International Space Station, and we carry out a further analysis back on Earth. So it is quite very similar. So we are carrying out analysis, and we'll be publishing soon.
Okay. And how was the rest of your team selected?
So I basically got in touch with friends of mine because I had worked with them previously on StritSat project. So I had known them for a long time and their experiences and qualification. So, and then they got in touch with other people, and we went through their qualifications and experiences and tried to match our requirements, because the team had to have all these different positions like scientist, biologist, astronomer, and engineer, and geologist, and so on. So we tried to reach to people who had these experiences and qualification.
Makes sense. What was the hardest part of the EVA?
Carrying the life support system itself, because that would weigh around 20 kilos. So carrying out anything and any experiments, for example, bending to collect the soil samples, and doing anything, wearing gloves and handling cameras or trying to control drone, all these things. But the biggest challenge was to carry that life support system, which weighed 20 kilos, and walk around. So that was the biggest challenge.
And were you assessed during the mission and given feedback at the end?
Well, we were given feedback almost every day, like when we send the reports or when we report any problems or issues, then the mission support would come back to us immediately. And if there is something wrong, or if they're not happy, or if there is something that we could improve to do certain things, or the way we are doing, we were told. So, there was nothing like an exam or we were given any marks or anything. But then if there were any issues, we were told to correct or change immediately, like the same day when we report them to mission support. But then we did not personally, or our crew did not have any issues, or they were very impressed that looking at the way we handled the water issue, because they did not expect us to go about having that long pipe and sucking the air from the other end and doing all those things, but they were really impressed with that.
Okay, this is a good question. Which difficulties did you have in managing the team?
So basically, I think in any given team, not all people will have the same mindset or same commitment levels. So bringing that to a certain level and coordinating with people and making them complete their task in a specific time was the biggest challenge. And also there will be small things like getting up early. Some people would not prefer that, but then we had to do that in order to carry out all the planned activities throughout the day, and also probably doing the reports that sometimes they were not sent in time, and we had to cope up with all those last minute things. There were many challenges, but then at the same time we had the best team. Everyone really cooperated very well and supported each other when others were in difficult times, and the entire mission was really, really good. And even the director of MDRS at the end said, this is one of the teams who are going out with such a smiling face. So you all have worked together really well, and you all still talk and be in touch with other people. And even today, we all still talk, and we have meetings even after MDRS. That's a good thing.
Oh, that's nice. Was there any moment where you thought you would fail the mission?
Not really fail. Fail is probably the hard word, but there were times where we were a bit unhappy about situations, and especially when things like there was no water at all. But then we took that as a challenge and we tried to overcome that. So I wouldn't say there was any situation where we thought we failed. Or also when there was one situation where the ATV broke down in middle of the desert, and those crew members handled it really well. They first figured out what the problem was, and they fixed it, and they got the ATV back to the hab. So all these things were appreciated by the director and from mission support as well. So that was all good. We didn't have such times.
Okay, so I guess the last question is, would you go back and would you recommend it to others?
Oh, definitely, yes. I would go back anytime, and I would definitely recommend it to others as well, because it's one of the experiences that you can have in lifetimes.
Okay, that's all our questions. Thank you, Mamatha. That was really interesting.
Thank you so much. Bye.
So I'd just like to say thank you very much, Mamatha, for being our first presentation, and a very, very interesting presentation. Excellent to hear all about the Mars Desert Research Station. We will hopefully have this on YouTube, so for people watching online later, do leave a message in the comment section if you have any questions. We'll also try to answer those. So thank you very much.
Thank you.